guys, so this is section 5.4 called solving radical equations. So we've graphed them, now we're going to solve them. We are cruising through chapter 5, so let's take a look at our first example. Solve an equation with one radical. So here is what it would look like. The square root of x plus 5 minus 1 equals 3. When we're solving equations, the first thing we need to do is isolate the radical. So here's the radical. I need to get this term by itself, so then I can get rid of that radical. Okay, and we're going to talk about how to get rid of the radical in a second. Before I can do that, let's move this 1 to the other side. So I'm going to add 1 to both sides. So then I'm going to have the square root of x plus 5 equals 4. My next step is this next line here. So I need to get rid of a square root. Okay, so what's the opposite of a square root? A square. So what we need to do is then square both sides. So notice in the black writing there, I square both sides, and what that does is it cancels the square root out with the square. So what I'll be left with is x plus 5, my radical is gone, equals 16. I got 16 from doing 4 squared. Simple equation here on out, all I have to do is get x alone. So I'm going to subtract 5 on both sides and get 11. And that's it, guys. I want to check my answer for sure though. So all I do is I just check by plugging it back in to my original equation here. So I do the square root of 11 plus 5 minus 1. Does that equal 3? 11 plus 5 gives me 16. Square root of 16 is 4. 4 minus 1 does give me 3. Awesome. Let's take a look at another one. Okay, whoops. Solve this radical equation. Here I have the cube root of x plus 2 equals 4. Remember this first step. First, isolate the radical. So I have the cube root of x I need to get by itself. I'm going to move the 2 over, and I'll be left with the cube root of x equals 2. So before, it was the square root I needed to get rid of, so I squared both sides. What do you think I'm going to do to get rid of a cube root? I'm going to cube both sides. Okay, so when I cube both sides, I'm then going to get rid of the radical, and I'll be left with x equals 2 cubed, I know is 8. And again, I can check this by plugging it back into the original. The cube root of 8 plus 2, does that equal 4? The cube root of 8 is 2. 2 plus 2 equals 4. We are good to go. Okay, so this is how we solve radical equations. Okay, when I just have one radical like this. Let's take a look at another type of example that we might see. So here we have a little review of some vocab. I need to be careful of this extraneous solutions that I can get. Remember, an extraneous solution is a solution that would be a solution to my original equation, but it is, an extraneous solution is a solution to my derived equation, the equation that I got after I did a whole bunch of things to it, added to both sides, squared both sides, but when I plug it into the original, it is not a solution. We went back to talk about extraneous solutions in the beginning of, was it chapter 5 maybe, when it was excluded from the domain, right? I excluded something from my domain because it did not fit the original. So when I get something at the end that says, oh, this should be an answer, but I excluded it from my original domain, that means it's an extraneous solution. So we have to be on the lookout for that. And we just check this at the end, just like I did in the first few examples. So this next example we're going to look at looks like this. The square root of 3x minus 2 equals x minus 4. So usually our first step is to isolate the radical. Well, it's already isolated. So how do I get rid of a radical? I square both sides. Okay, by squaring both sides, then I can write that like this. Square this side, and then square this side. By squaring both sides, the radical goes away. And I have to remember, how do I handle x minus 4 squared? We have to remember x minus 4 squared is x minus 4 times x minus 4. We do not distribute the 2. That's like that meme I have hanging up in my classroom. oh, I miss it. That like we now have to FOIL this. Okay, so we're gonna FOIL, and when I FOIL, I'm gonna be left with x squared minus 8x plus 16. From there, what we do is I have to get everything to one side. Okay, I have things on both sides of my equations, so I'm going to get everything to one side to make it a little bit easier, and so I can solve for x. Remember, this goes back something that we learned in the beginning of the year. Which side do I get things to? Anybody remember what the rule was? We get everything to the side to keep that a coefficient positive. The greatest degree, the coefficient of the greatest degree should be positive. It's positive right now, so we'll keep it positive. And I'll move everything over to this side. So I'm going to subtract the 3x. It's going to become negative 11x, and I'm going to add 2, becomes 18. What do I do here? Now, how am I going to solve this? That should look like, okay, well, I have a quadratic. How do I know to solve quadratics? By factoring. So I'm going to make the chart. Two numbers that multiply to 18 add to negative 11. Weird. What's it going to be? Negative 9 and negative 2. Anybody remember now with quadratics, how do I solve that for x? What's the property I have to do? The zero product property, which means I have to set each of those factors equal to 0 and solve for x. So I get x equals 9 and x equals 2. Let's check back to my original to make sure that I do not have an extraneous solution here. Okay, so when we keep scrolling here, hopefully, yep, let's check for potential extraneous solution. So when I go back to my original, here I'm going to put a 9 in for x and a 9 in for x. 3 times 9 gives me 27. 27 minus 2 gives me 25. 9 minus 4 gives me 5. The square root of 25 equals 5. When I plug the 2 in for this x and the 2 in for this x, 3 times 2 gives me 6. 6 minus 2 gives me 4. The square root of 4 gives me 2. 2 minus 4 gives me negative 2. This does not work. This is not a solution. This is an extraneous solution. You might be thinking, well, how come when we were solving before, a square root could give me a positive and a negative answer? When we're solving for a variable, so when there's an x involved, when an equation says x squared equals 4, here my x could be two things. This equation will be true when x is a 2 and a negative 2. There are two solutions to that. When I'm just simplifying, there's not a variable, I'm just simplifying numbers, I could type this right into a calculator. What's it going to tell me? 2. That's when I could get an extraneous solution. So when there's a variable, I'll have a positive and negative. When I'm just simplifying numbers, I will not be getting two answers. Okay, so that's why I just have one answer, x equals 9, for this example. Okay, be careful with those extraneous solutions. I'm going to stop here. The next video, we're going to talk about rational exponents. Remember rational exponents? That's what happens when I have a fraction. Oh no, when I have a fraction in my exponent. So you want to hop on the next video so I could talk about it. Good luck, guys. Awesome job.